In this activity, we're going to illustrate some properties of quadratic equations using sundae cups. Materials that we need for this activity are several sundae cups that are shaped in a curve like a parabola, some colored paper, some graph paper, note cards, a pair of scissors, and some tape will be helpful. Okay, what I'm going to do is I'm going to take one of the sheets of paper and one of the sundae cups, and I'm going to place the sundae cup sideways along the piece of paper, and then I'm going to, holding the pencil straight up and down, I'm going to trace the outline of the sundae cup. Then I'm going to cut it out of the paper. Here is the outline of the sundae cup, and I placed it on my coordinate plane. From here, I placed it so that the vertex is at the origin and the axis of symmetry is the y-axis, and it's right through the center of the outline. From here, I can read off the data points, the 0, 0, and like 1/2, and as I look at this, I can get my data points, which I've listed right here. I listed them below right here. Here are my data points for this particular cup. As I get my data points, I can also run them through the calculator, and I can obtain my quadratic regression line, which gives me my A is 0.375, my B is negative 0.32, and C is 0.095. My R squared, my correlation coefficient, is 0.994, so I see it's a very strong correlation. My points are lined up in the pattern of a quadratic, and I also see that my value for C, which is where it crosses the y-axis when it's calculated, is not quite at 0, 0, but it's close. Okay, I'm going to do this for the rest of the cups, and I'm going to see what I come up with for my data points and for my lines of best fit, my quadratic regression lines. For the second cup, I already traced the outline, and then I placed it so that the vertex is at the origin and the axis of symmetry is the y-axis, and from here I can read off my data points. Okay, here are the data points, and we see that the domain only goes to an x equals 3, because then we get a vertical line. This next sundae cup, I traced the outline in green, and then I cut it out and I placed it so that the vertex is at the origin, the axis of symmetry is the y-axis, and then these are the data points that I obtained. This fourth sundae cup that I used, I traced the outline in yellow, and again I placed the vertex at the origin, and the axis of symmetry is the y-axis, and then from here I obtained the different data points. I try to get about 8 or 9 data points so I can run it through the calculator to get the quadratic regression. So what I'm going to do next is I'm going to put them in order from the narrowest to the widest parabola. And I see that the pink one is the narrowest, so I'm going to place that one first. Then the orange, then the yellow, and then the green. Now looking at the shape of the cup or the shape of the outline, you can see that they go from left to right. They go from the narrowest to the widest. I'm going to slide these down so we can see the line of best fit. That was calculated for each one of the parabolas. And what we see for the first one is we see that the coefficient in front of the x squared term for the first one is 0.75. And our r squared is 0.99. For the second one, our coefficient for the a squared term is 0.375. For the third one, our coefficient is in front of the x squared term is 0.222. And for the last one, our coefficient is 0.174. So what we notice is that in each one of the graphs, each one of the equations, as the cup gets wider, the coefficient in front of the a squared term gets narrower. When we look at the sundae cups in order from left to right, as they get wider, we see that the coefficient in front of the x squared term, the a, becomes smaller. And that's because when we multiply by a number less than 1, the height is going to be smaller, and so the graph is going to become wider. And when we look at these last two here, we see that the a term, the coefficient in front of the x squared term, is 0.222, and over here it's 0.174. They're very similar, and when I put the cutouts together, we see that the quadratic part of my two cutouts are in fact very, very similar. What I want you to see is that as the cups get wider, the coefficient in front of the x squared term becomes smaller. And that concludes this experiment. Thank you.